All right, it's time to now solve a lot of exponential equations here. This first one is 4 to the x is equal to 64. One thing you might do to solve this is take the natural log of both sides, writing this as the ln of 4 to the x is equal to the ln of 64. Then I can use my third law of logarithms to bring this x out in front, writing it as x times the natural log of 4 is equal to the natural log of 64. And I can divide both sides by natural log of 4, leaving me with x as the natural log of 64 over the natural log of 4. That's my final answer. There's actually another way we could have done this. You might recognize that 64 is actually 4 to the third power. We could also try this with our second technique of trying to write these exponentials as the same base. Even though the right side doesn't really look like an exponential right now, we could write it like one. So we would write 4 to the x is equal to 4 to the third power. And now that I have my bases the same, and I can go ahead and equate those powers and then get x equals 3 as my solution. Now, you might look at this and go, well, we must have done something wrong because one technique we solved it and we got 3, and the other technique we used and we got ln of 64 over 4, and those look really different. But actually, if you were to put natural log of 64 divided by natural log of 4 into your calculator, you would get 3. I know it's kind of weird, but let me show you why. Remember that change of base formula that looked something like this? We have a really similar setup here where I have a natural log divided by a natural log. In this case, my x is like my 64 and my a is like my 4. And so I can actually use my change of base formula to write this as log base 4 of 64. And then we practice evaluating logs, and I know that log base 4 of 64 is going to be equal to 3 because 4 to the third power is 64. So actually, we get the same answer for both of these. In this next one, I'm really tempted to start by taking the natural log of both sides of the equation. Unfortunately, when I do that, I get a little bit stuck. In the previous examples, as soon as I took the natural log of both sides, I was able to take this exponent down as a multiplier in front. But I can't do that here because of this plus in the middle. My laws of logarithm say that if I have log of base to a power, then that power can come out in front. But that's not what I have here. I have a number plus a base to a power. There's too much going on here. And so I'm not going to be able to go much further from this. Instead, I want to be able to isolate my exponential first. Let's get rid of that plus 2 before I take the natural log. I'm going to do that by subtracting 2 from both sides of the equation, giving me 4 to the x minus 3 is equal to 5. Now when I take the natural log of both sides of the equation, I will be able to bring that exponent as a multiplier out in front. I can divide both sides by natural log of 4, and then add 3, giving me my final answer. So the key in this problem was to isolate the exponential before we took the natural log of both sides. In C, I want to use that same idea. Before I take the natural log of both sides, I want to get rid of this 4 that's multiplying in front of my exponential. I'll do that by dividing both sides by 4, and I'll get the e to the 3x is equal to 5 over 2. Now I can take the natural log of both sides of the equation. I can either think about bringing this 3x out in front and then simplifying the ln of e, or in this case, I can actually use my cancellation properties because the natural log and e will undo each other, and I'll be left with 3x is equal to the natural log of 5 halves, or x is the natural log of 5 halves divided by 3. We do need to stop here. We're not going to be able to combine the 5 halves and the 3 together because the 5 halves is inside of that natural log. In D, what technique do you think we're going to try to use here? It might take a second to realize, but 216 actually is a power of 6. 6 squared is 36, and 6 to the third power is 216. And so I can write the 216 to the x plus 1 as 6 to the third to the x plus 1 power. We can use our exponential rules to write this as 6 to the 3 times x plus 1 power. And now I can go ahead and equate those exponents, giving me 2x equals 3 times x plus 1. Now all I have is a linear equation. I can start with distributing this 3 across and get 2x equals 3x plus 3. I can subtract 3x to get my x's together and get negative x equals 3. And then divide by -1 to get x equals -3 as my final answer. I'm going to let you try this part on your own. Pause the video and then I'll talk through how to do this problem. All right, here's what I did. I started with taking the natural log of both sides of the equation. When I did that, I was able to use the cancellation property and end up with 3 minus 2x equals natural log of 4. And then I needed to subtract 3 and then divide by -2 in order to get my x by itself. All right, why don't you try this one by yourself as well? Pause the video now and press play when you're ready. And here's what I did. I started with recognizing that 27 actually is the power of 3. And so I could write 3 to the third to the x is equal to 3 to the x plus 4. Then I wrote that power as 3x, multiplying those powers together. Once I did that, I was ready to equate my powers and ended up with 3x equals x plus 4. That left me with a linear equation, which I solved by subtracting x and then dividing by 2. How'd you do? All right, let's try this last problem together. Here I see that I have exponentials on both sides of the equation, and so I am tempted to try to write the bases as the same base, but I don't think I'm gonna be able to do that. I look at the 4 and the 5, and they don't have anything in common. This is very different than comparing 4 and 64 and 3 and 27. 4 and 5 are not powers of each other. So the only technique that I can use here is to take the natural log of both sides of the equation. Giving me the natural log of 4 to the 2x is equal to the natural log of 5 to the x minus 1. Now on both sides here, I have a log of a base to a power, and so the powers can come out in front as a multiplier according to my third law of logarithms, giving me 2x times the natural log of 4 is equal to x minus 1 times the natural log of 5. Now this is a little bit tricky to be able to solve here. What I need to do is get all my x's on the same side of the equation and get my things without x's on the other side of the equation. In order to do that, I need to distribute this ln of 5 across, giving me 2x times the ln of 4 is equal to x ln of 5 minus ln of 5. Then to get all my x's on the same side of the equation, I'm going to subtract x ln of 5. Leaving me with 2x ln of 4 minus x ln of 5 is equal to negative ln of 5. Now, you might be tempted to divide everything by 2 ln of 4 to get this x by itself, or maybe divide everything by ln of 5 to get this x by itself. But since I need to divide by different things to get each x by itself, that's not going to work. Instead, what I need to do is factor the x out. When I do that, it's going to look like 2 ln of 4 minus ln of 5 all times x is equal to negative ln of 5. And while this is a gross number, this is just a number here. 2 ln of 4 minus ln of 5 is a number that is glued to this x with multiplication, and I can undo that by dividing both sides by 2 ln of 4 minus ln of 5. And when I do that, it'll cancel, and I'll be left with x equals negative ln of 5 all over 2 ln of 4 minus ln of 5 as my final answer. Now, that is a pretty gross answer, but it is the answer in an exact answer. Sometimes in the homework, I might ask you for an approximation, so you would have to put this in the calculator. When you do that, you want to be careful about putting parentheses around your denominator so you get the correct approximation. But in cases when you're just asked for the exact answer, this is good to go. All right, so we just solved a lot of exponential equations. This should get you ready to work on the homework and on the learning assignment. So happy solving exponential equations.